what I want to start with is just a little bit of a reminder of the four main functions that we deal with in paper one. So I think of this section, I think of the straight line, I think of the parabola, I think of the hyperbola, and I think of the exponential function. So step one for this is you have to be able to identify them, and either they give you these functions in like formula form, or they give you a visual representation. So if you're using formulas, the standard form of a straight line would just be y equals mx plus c, or sometimes they'll write it as f of x equals mx plus c, where m is the gradient and the c is the y-intercept. And I'm pretty confident you guys all know that. Now, what got a bit harder in grade 11 was the parabola suddenly has the standard form that looks like this. And then we also have what's called the alternate form of a parabola, which looks like that. Then we have our hyperbola, which looks like that. And then we have our exponential function, which looks a bit like this. Now, if I'm scanning to see whether something is a parabola, I'm looking for the power of 2 is how I recognize parabolas. And if I am looking for hyperbolas, I'm looking for an x in the denominator. And if I'm looking for exponential functions, I'm looking for the x as the exponent. So that's how you would recognize these. The other values, like a, kind of affect the steepness of the graph, and then the p affects the horizontal shift, and the q affects the vertical shift. Now, I don't want to do too much at once, so I want to give a chance. If you are familiar with all this stuff, give me a smiley face. If you're unfamiliar, I want you to give me an unhappy face, and if you're somewhere in the middle, give me one of those faces. Okay. Now, there are a few more things we need to know, in that if I have to visually, or let's talk about asymptotes and turning points and stuff. These graphs 2, 3, and 4 are what we call curved graphs, whereas number 1 is a straight line graph. Now, the parabola has what's called an axis of symmetry, or AS. So if I'm visualizing a parabola, it can either be an unhappy parabola like that, or it can be a happy parabola that looks maybe something like that. And a parabola has a turning point and an axis of symmetry. So the turning points would be here and here, and the axis of symmetry would be going through the turning point. It literally cuts the graph in half. So that's some of the special information we need to remember about the parabola. For the hyperbola has not just an axis of symmetry, but it also has what's called an asymptote. So if I'm visualizing hyperbolas, I'll do the 2 different types here. Often we will have like an asymptote that goes this way, and we'll also have an asymptote that goes that way. And let me do. Now, the asymptotes are lines that cannot be crossed. If the hyperbola has a value that's positive, so if a is greater than 0, it will look something like that. Oh, let me redo that. So if it's kind of like a happy hyperbola, it looks like that. If a is less than 0, and I'm talking about this a here, then the hyperbola will be in these quadrants. Now, there's a lot more going on with hyperbolas. Can I get a face feedback about hyperbolas if you're following what I'm saying here? Give me a face smile or frown if you are following what I'm saying here. Okay, now, so we can see our asymptotes on the hyperbola. Now, what about the axes of symmetry? The axis of symmetry cut these two graphs in half. And so the axis of symmetry is going to be going through where the two asymptotes meet. So that would be the axis of symmetry. I know it looks a bit messy, but I just want you to have some awareness of what the axis of symmetry actually is. You can see how you can fold these graphs across these dotted lines. And so students, because they sound quite familiar, they sometimes mix up the axis of symmetry with the asymptotes. And so I suggest looking at this until you feel comfortable. Okay, and then the last function that you need to be aware of is the exponential function. The only thing the exponential function has is an asymptote. I mean, it also has intercepts, but they all have intercepts. And so if we talk about a exponential function, if I draw in, let's say, an asymptote that is there or an asymptote that is there, we generally have an exponential function that goes like that, which is an increasing one, or we can also have one that goes like this, which is called a decreasing exponential. And so that's an example. The a value over here will affect whether this would be a is greater than naught and this would be a is less than naught. Give me another smiley face feedback about whether you understand that basic shape. And be brutally honest, there's no use hiding where you're at. I just, because the rest of my lesson is formed from these impressions that you are giving here. Okay. Then, is there anything else I want to tell you about? In order to do functions, you need to be able to find the intercepts. So I want to know, how do I find the x-intercepts of any function here? How do I find the x-intercepts of any function here? You are going to make y equal to 0. And how do I find the y-intercepts? Okay, you're going to make x equal to 0. Okay, so there are more questions, but for me, these are the basic ideas that you need to have in your head ready to roll at any point. Now, that concludes my quick little summary of functions. Let's go and look at some questions here. So what I want to do is I want you to try and do question 1 and 2 for me. There are 3 options here. So we'll say number 1, actually, let's make it A, B, C. So A, B, C, A, B, C. And you are going to try and do question 1 and question 2 for me. So if you think the answer is 1C, you put 1C in the chat. If you think the answer is A, you put 2A in the chat. And let's just see what you remember about answering these questions. So you're finding the asymptotes of this hyperbola. Because this is a hyperbola. How do you find the asymptotes of a hyperbola? Well, there's 2 asymptotes. The one part you have to look at is there, and the other part you have to look at is there. Now, for an asymptote to happen, x plus 2 must be 0. So x is minus 2 is one asymptote, And then the other asymptote is just going to be -4. So is there an option that matches that? My option is going to be 1B for the first one. Now, if you're unsure about how I got 1B, please put your hand up and ask a question, because I'd love to discuss it further. Otherwise, I'm going to just let you go on to question 2. Okay, Amangile. So if we talk about the hyperbola, it has 2 asymptotes. And the first asymptote we get by making sure that this denominator is 0. So we say to ourselves, x plus 2 is 0. It has to be 0 in order to be undefined and have the asymptote. So I say x plus 2 is 0, and then I solve for x, and I get x is -2. And that will be the asymptote that looks like that. The other asymptote is just going to be the number that comes after the fraction, in which case it's going to be the one that looks like this. So that's going to be y is -4, and then this one over here was x is -2. To find the x-intercept, I need to make y equal to 0. And so I need you to solve that equation for me. And I think I'd probably move the 4 to the other side. And then I would multiply both sides by x plus 2. So I get 4 times. Now you still have to get to the end for me. So you have to go 4x plus 8 is 1. And then if I move the 8 across, I get 4x is -7. And then if I divide it by 4, I should get -7/4. So my answer is going to be 2C. Notice how I made y 0, and then after that, all I was doing algebra to isolate the x. And this is giving me the x-intercept of this hyperbola. Are there any questions about 2? Otherwise, I'm going to move on to question 3. Find the range of the following function. So what is the range? And the same hyperbola that we've been dealing with so far. What is the range of the following function? And we kind of know, like, we know where the asymptotes are. We know there's an asymptote at x is -2. And we know there is an asymptote at y equals -4. So now the question is, if this is a positive number, the hyperbola will look something like, okay, it's not perfect. Apologies for my dodgy thing there. But it feels to me like it will look something like that. Now, the only y value that is being excluded is going to be -4. Every other y value is going to be okay, but we can't have y equals -4 because that's going to be on the dotted line. So which option do we think is going to be relevant for this one? I think that can't be right. That can't be right. So y can be any real number, but y cannot be -4. And that's because the asymptote is at -4. And so my answer here would be 3A. Okay, so I'm going to let you have a crack at number 4. But for those students who are feeling lost, I'm going to ask you to raise your hand or ask a question in the chat. Find the domain of the following function. Well, we kind of know that it can be a real number, but what's the one number we have to exclude? We have to exclude the -2 because there's an asymptote where x is -2. So the correct answer is going to be that one, which is 4C. Yeah. So I think you can see how this is being connected. So let's keep on rolling. Now, this is a slightly different type of question. This next bit, if I can get my mouse to behave, we're now talking about intersection points. So let's just take a moment to think about how this is different. So find the x coordinates of the following intersection points of the following two functions. So this g is a hyperbola. So g of x is a hyperbola. It's just not a very exciting hyperbola. And h of x is a straight line. How do we find intersection points for two functions again? Can anyone remember how we do that? I see in the chat there is some information coming along. If I think about what the hyperbola would look like, so that's the hyperbola, and then a straight line, it's x plus 1. So what you're really trying to do is you're trying to figure out what are the x values of those two green dots. So Fateko has said make them equal. Ayanda has said equate them. Tsepo has said simultaneously. I agree. All you need to do is you need to equate them, and then you need to solve that question. So I will let you do that by yourself and tell me which of the 3 options you think is correct. Can you remember how to solve a quadratic equation? So you can multiply both sides by x, or you can imagine bringing the x across. And then what you need to do is move everything to one side. So you need to solve that. And then you've got the choice of the quadratic equation, or if you're feeling confident in your factorizing, and this is not too bad, 3 and 2 make 6. And I'll make that a plus and that a minus. So x plus 3 is 0, or so which of the 3 options do we think it is? X is -3 or x is 2. So to me, it looks like 5C. Okay, let's see. Again, if I'm going too fast, please do let me know in the chat. But otherwise, let's go on to number 6, where you have to evaluate using function notation. What is the h of 2 minus the g of 6? So you have to interpret what that is and then evaluate that. So the h of 2 means just to put a 2 where the x is. And so for me, the h of 2 must be 3. And the g of 6 is 6 over 6, which is 1. So what is the h of 2 minus the g of 6 going to be? So the h of 2 came first, and that was 3, minus the g of 6, which is 1. I should get 2, which is the third option, or we would say it's also going to be C. So it's 6C. Okay. Thumbs up if you could follow that. Thumbs down if you couldn't follow it. This is just using what we call function notation. So function notation, what does the h of 2 mean? It means put 2 into the function h, and what do you get out? You get 3. Find the g of 6, put 6 into the function g. What do we get out? 6 over 6, which is 1. And then we subtract them. Okay, now, before we move on to the next, or before we take a break, I want to talk about this last question. So it says, find the equations of the straight lines that represent the axis of symmetry for the following function. Now, this function over here is the same hyperbola we've been doing all along. So if you have to imagine visualizing this hyperbola, we said for a while that this is going to be at y equals minus 4. That's the one asymptote I need to bear in mind. And then the other thing I need to bear in mind is that x is minus 2. So that's the other asymptote. Now, because this value is a 1, what's going to happen is that, and I don't know the exact value of where it cuts there, but this is what the hyperbola is going to look like. Now, what are they asking about? They talk about the axis of symmetry. The axis of symmetry, do I have a different color I can use? Let me use a highlighter which stands out. The axis of symmetry is going to be the straight line that goes through that point over there. What is that point over there, that big? Can somebody tell me what the coordinates are for that point over there? What are the coordinates of that pink point going to be? So I look at it's in line with minus 2, and it is in line with minus 4. So this pink point is on each of the axis of symmetry. Now, there's something else that is awesome. The axis of symmetry of a hyperbola will always have 2, and the one will have a gradient of +1, and the other will have a gradient of -1. Now, I want you to use the fact that you've got the gradient and you've got a point on the line to find me the equations of these two lines and then identify which of the 3 options here is correct. So over to you guys to figure out which of those 3 options is correct. I'm going to give you a minute or so, or maybe 2 minutes to do that. And then we're going to take a break. See what you can get. Oh, this should be -4. Sorry, I wrote that wrong. That should be -4, and that should be -2. So that's -4, and that's -2. Oh, wait, what's going on here? That's +2 plus C. Yep. So we now have, so the equation of this one is going to be y equals x minus 2. And the equation of this one is going to be y equals -x minus 6. Which of the three options is correct here? X minus 2 minus x minus 6. So for me, I don't think it's going to be 7C. I see quite a few students saying 7C. But if I look at my options, 1x minus 2. So it can't be B. But as I look at C, this is -x. Yeah, so it should be 7C. Now, that is quite a toughie. So I just want to say this one more time. To find the axis of symmetry of a hyperbola, you go to the point where the two asymptotes are hitting into each other. And that was the point -2, -4. Then there will be two of them. The one has a positive gradient of 1. The other one has a negative gradient of 1. So I set them up like this. And I sub in the point that I was using over here. Then I solve for C, and I write it out. Oh, I lie. Guys, I'm making it up. Sorry. -x. It should be A. It should be A. Hey, yo, having a moment there. So at least you can see my numbers are matching A. So that was me just being a noner. So give me a thumbs up if you understand now. All right. Cool. Well, I have pushed you guys quite hard in this first bit. So what I want is I want everyone to stand up with me. And I want us to take a hard-earned rest. And I want you to start by just loosening up your arms. I'm sure they're a bit tight after that last question. So just loosen them up. Let's check out your legs. Get that circulation moving. And then let's take some nice deep breaths. Hold. Yeah. Then let's start with just some small circles, going into big circles. And then let's change the direction, big circles into small circles. And then shake out the arms again. Let's do a tricep. And then let's loosen up again. Let's just do some rotation. So a nice gentle rotation. And then as we relax, we can just go like this. Yeah. And then let's do some heart rate raising activities. So we're going to do some air skipping, and we'll do about 20 of them. So we'll start in 3, 2, 1. Let's go. And that is that. Okay. And then before, we don't want to not do a bit of maths 24. So here are your options for tonight. See if you can solve any of those maths 24 puzzles. Okay, so Andile has said 5 minus 1 times 6 times 1, which I agree is 24. So Andile has taken the red card. And then let's see about blue and yellow. Emmanuel has said 9 minus 8 gives me 1, plus 5 would give me 6, but then I must put another bracket around it, and then times 4 would give me 24. And then I think Josh has taken the yellow one, because you go 5 times 6, which gives you 30, minus 7 minus 1. Now, 7 minus 1 is 6. So we have 30 minus 6, which gives us 24. Yep, Josh, you are quite correct. So well done to Josh, Emmanuel, and Andile. Let's get back to our lesson. Cool. Okay, so I hope you feel like you've had a bit of a break. Your brain has had a chance to recuperate. Let's look at this question here. Rihan wants to solve this pair of simultaneous equations by substitution. Which of the following is the correct line of working? So we have 4 options there. And if you think about the techniques you use to solve a simultaneous equation, one of them is substitution. And which of the 4 options do you think here is correct? So with substitution, we normally take the easy one and sub it into the harder looking one. And what I like to do is I leave a blank space where I would normally be substituting. In this case, it would have to be 5 minus 2x. But I don't see anything that looks like that. So you may have to look a bit deeper. Suppose I could expand this. So is there anything? Okay, this is looking good. So 3x plus 10 minus 4x. So clearly the answer would be that. And just to show you, if I needed, said here wants to solve this. Now, these 2 equations, these 2 straight lines will find you a intersection point. And to find the x coordinate of that, you have to solve this equation. But yeah, I think you probably can do that. So I'm going to leave that for now. So, okay, let's look at a past exam question here. So this is from the DBE 2017 grade 11 paper. And I want you to do by yourself now 1.1 to 1.3. See if you can do those three questions by yourself. And when you feel like you've done those three, just say done in the chat. If you have a question that you'd like to ask, I want you to just raise your hand or ask it in the chat. I'm just going to top up my water while I... What do we need to do for 1.2? We're a little stuck here. What is the next step that unlocks the important bits here? So Josh has said the same base. Josh, I agree, because I noticed that 8 can be written as 2 to the power of 3 equals. So now, if the whole sides are equal to each other and the bases are equal, these two must be equal. And then if I divide both sides by -1, I should get that x is equal to -3 in this case. So the correct answer for 1.2 is that x equals -3. Write down the asymptotes of f. So luckily we did this earlier, and we just look at what will make this part 0. So this would be x is -2. And then the other part would be y is equal to 1. Those would be the two asymptotes of the hyperbola. Okay, I want us now to move on to 1.4 to 1.6. See if you can do 1.4 to 1.6 by yourself. If there are any questions about 1.1 to 1.3, I want you to raise your hand. I would love to hear a student's voice if anybody's feeling comfortable. Otherwise, I'll read the chat. So please re-explain 1.2. So for Tekel, if we look at 1.2, we know it refers to g of x. So that's this function over here. And it says if g of x is 4. So I replaced g of x for 4, and then I just left everything else the same. And then I moved the 4 across, so it became +4. 4 plus 4 is 8. Then I said 8 is 2 to the power of 3. And then I said that this must be equal to this. And then all I did was I moved the minus to the other side, and I got my final answer of x is -3. Now 1.4 also deals with g here, the function g. So g is an exponential function. And if I imagine this exponential function, there is an asymptote at -4. But what's important is the exponential function on this side or on this side? Now, normally, if it's a +2, the graph would just look like that. But there is a -x here. Now, the good news is all that a -x does is it reflects it over the y-axis. And so if it reflects it over the y-axis, instead of going, if you imagine the y-axis is here, to reflect it over the y-axis, it's just going to look like that. And so in this function, it may not go exactly through that. It probably goes through something else. So let me probably look something like that. And so when I say the range, I actually need to say that y is greater than -4, because it's going to be any value of y that is above this line. I can't include the stuff below -4. Another way of writing that would be to say, I can't include -4, so it must be a circular bracket. And then this could go to positive infinity. So that would mean the same thing. So if you you half right, but watch out that it can only be this bit here. Okay, can you do 1.5 and 1.6? That's the next part of the journey. Okay, so my y-intercept is 0 minus half, and my x-intercept is 1, 0. So it's just 1.6 we're trying to do now. And it says, what is the equation of the axis of symmetry of F, which has a negative gradient? Now, it might be helpful to have a bit of a sketch here to help us. So we know that x is minus 2 is one asymptote, and y is 1 is the other. Because there's a negative number here, minus 3, because there's a negative number, when I draw this graph, it's going to be in this quadrant, and it's going to be, okay, it may not go exactly through there. Is it going to be positive or negative? We worked it out. Oh, we've worked it out already. It's going to be negative, and then, wait. The y-intercept was 0, -1/2, so we know it has to cut this there, and then that has to cut at 1. So what are they asking you to do? What they're asking you to do is they want to know the equation of the straight line that goes through that pink dot and it's like that. And the thing that you really need to know is that the axis of symmetry of a hyperbola will always be 1 or -1. Because this axis of symmetry is negative, we know the gradient is -1 here. Now, all you need to do is think about what is the coordinate of this big pink dot. Who can tell me the coordinate of this big pink dot here? So if I look at what it goes through x is -2. So it definitely is going to be -2, and then it goes through 1. So what you need is you need the equation of the purple dotted line that has a gradient of -1x, and you don't know what the y-intercept is, but you do know that the point -2, 1 is on this line. Can you find the equation of this pink axis of symmetry here for me? What do we need to do to figure out the entire so I think wherever there's a y, I'm going to leave a blank space, and I'm going to put into that 1 and then a -2 for the x. -1 times -2 is 2. That's 1. If I bring the 2 across, I get 1 - 2. So c must be -1. And then the final equation of my axis of symmetry is going to be -x or -1x -1. And so that is going to be the equation of the axis of symmetry that has a negative gradient. If I wanted to find the one that goes this way, the only thing that would change is the gradient of the green luminous line would have a gradient of +1. But the working out would be exactly the same. But they didn't ask for that, so I'm just throwing that in there. Now, give me a thumbs up if you followed that last bit. That was a bit of tricky stuff. Are there any questions about anything from 1.1 to 1.6? Anything that you would like to query or just get a bit of a better understanding? Okay. So we've actually done quite a lot today. And so I think this is a good time to call it a day. You can see the last question is just to sketch the graph, but the only thing I've left out here is you would need to label all the asymptotes and intercepts. So you'd have to label kind of the intercepts, and then you would have to draw in the exponential. But all you would do is you would find the intercepts, and that's fairly straightforward. So I'm just going to show you what we're going to do in the next lesson. So I just want to give you a feel for the different types of functions. So in the next lesson, we'll probably do something like this, where we have parabolas and straight lines. We'll also probably look at questions where we have parabolas and hyperbolas on the same thing. And then we'll probably just do a mixture of other functions. So that's what we're going to do on Wednesday.